All right. Hello, everyone. I'm Jack. This week I will be doing the lecture, and Rahi will be doing the demo. I'm going to lecture today about databases. It's going to be really fun. So let's start with some review. Um, Last lecture, you learned about the client-server model. You learned that clients are computers. They talk to other computers that are servers by sending them requests, and the servers reply with responses. Um, Requests, of course, they're initiated by the client. Uh, they're sent to a specific URL, for example, google.com. A URL contains the domain, a path, and URL parameters, which are optional. And they also have associated with them a method indicating the nature of a request. Now, of course, the path tells us more specifically, what we're kind of looking for on each server. We also send meaningful data in the body of a request. In this class, we use JSON, but any arbitrary encoding can be sent in the body of the request as long as you're prepared to decode it on the server. We will stick with JSON because it's nice, simple, and easy. Of course, on the other hand, the server returns a response, which is triggered by the client request. It is a confirmation of the requested operation. It uses response codes like 200, 500, 404 to indicate what kind of success we've had, and it can return a body, also containing anything, but in this class, JSON, because it's very nice to work with. So we can get all kinds of data back from the server. So just to show that in a diagram again, the client initiates a request to the server. The server then triggers the correct route based on the path. And the rest of that animation isn't there. But it returns a response. Thanks, Rahi, for animating that so fully. Anyway. So now that we've reviewed a little bit, let's talk about data persistence. This week, last week's assignment, you built a sort of Reddit-like forum software, and you probably stored your posts on this forum software something like this in a global variable with an ID that you incremented. But this isn't particularly good. We know that if the server crashes, all of the global variables that are stored in memory are going to be lost, and that data is going to be lost. It's also not going to scale very efficiently, and we don't have a lot of guarantees about this data because we can really put whatever we want into that dictionary. It's really not great. We're going to solve this by introducing databases. We can have much better storage. So a database is a collection of organized information. It's very easy to access, update, manage data, and it's implemented sort of as a collection of tables. So let's just dive right in and see a little bit what that means. One database table can be represented as an ordinary two-dimensional table on the page here. We can see we specify certain attributes that each entry in the table is going to have. We give them specific names and, importantly, data types. So each row comes to represent one instance of an item. So here we have some kind of fruit inventory. We have an ID for each fruit, where we also store the name of the fruit, how many fruit we have, and the price of the fruit. And each of these is guaranteed, each of these columns is guaranteed to contain the kind of data we want. The ID column is a little bit special. We've defined the ID column, and we'll show you how to define the ID column such that it is required to be unique for every item in the table. And this is important for the same reason that you had unique IDs in your global variable for your Reddit clone, so that we can direct reference any object, any entry in a table. These IDs can also be set to automatically increment when you add a new entry, which is very convenient. And also, IDs of removed items do not get reused. So if we remove banana there, the next element will still be 5, not 3. So it's important to remember, though, that a database is not just a table. A database is a set of multiple tables. So we can have a couple different tables in our example here, a kind of a grocery store example, perhaps, where we can store what kind of fruit we have here, how much fruit, how much the fruit costs, as well as some of the information about our employees, their names, ages, how much money they make. And each table has independent IDs. These tables exist completely independently of each other, just within the same unit of a database, which lets us connect them in some interesting ways a little bit later. So you can already see, just from a sort of visual representation, that the structured organization of the table is a bit just a bit easier to look at, easier to read than the more free form, let's have a list of objects with these various fields. Since our data is very uniform, we can represent it in a nice uniform way. So the benefits of a database are that all the data is structured. These scale incredibly well. Database servers are written by people much smarter than me, at least, who have done research into and spent their entire lives figuring out how to store data efficiently and effectively. And we can just take advantage of that. The third benefit is that we can query data. We can ask the database questions, and the database can actually do a lot of really cool things for us. So let's take a look at that. If we wanted to see which fruits are in stock in our grocery store example, we could write some code like this if we were storing all our fruit in a JSON file. We could open up the JSON file and iterate through all the fruits and build ourselves a list. We can also just ask the database this question. We can tell the database to select the name of each fruit from what fruit there are, where the quantity is greater than 0. Now, let's look at that in a little more depth. This is called structured query language, or SQL, or SQL, if you prefer. People pronounce it different ways. I'm in the SQL camp myself. But basically, this is a well-defined language for communicating with databases, and it's a standard mostly adhered to by a lot of database engines. Every database engine has their quirks, but for the most part, if you're working with MySQL or PostgreSQL or Microsoft SQL or whatever Oracle makes, you're going to be able to write in largely the same structured query language. So let's look at creating a table. Creating a table follows this basic format. We specify a table name, and then we specify, following it in parentheses, a list of columns and the data types for those columns. So for an example, we could have a users table to represent some users of our web service, perhaps the Reddit clone from last week. And we could say that we want an ID, which, as I mentioned earlier, we define specially. We say that it's going to be an integer. It's also going to be the primary key of the table. This is the single most important identifier. That implies that it must be unique. And we can also set it to auto-increment. So we don't ever have to specify. We don't ever have to come up with the ID ourselves. It will be automatically decided for us. And then we can also specify that the name and the age are going to be text fields that are not null, and that the email is going to be a 50-character maximum sequence of characters. Now, there's a lot of these data types that we can look at. You can look at documentation for, but we'll just be using a few of them today. You can also insert data by saying insert into, giving the name of a table, and then giving a list of column names followed by values and a list of values. So what that kind of looks like. Oh, you also don't have to include the columns if you're inserting values into all of the columns. So what that looks like is we'll specify if we're creating a new user, we'll simply say we want to insert into user. We'll specify we're inserting name, age, and email, since the ID we don't need to deal with. And we will say that the values we're inserting are the string John, the number 21, and then the string of John's hypothetical net ID. I think a few slides back, age should have been an integer and not a text field. Sorry about that. So, to retrieve the data, we can use a select statement. We can select a list of columns from a table name. Or we can use an asterisk to select all columns. We can also specify conditions. We only want to retrieve these columns from this table if something is true, or rather where something is true. So for example, we can select all of the fields of each user from the users table as long as they're 18 or older. We can also update data. This is all slightly inconsistent, but pretty similar, I think. Here we can use an update statement, specify a table name, and then set and specify a list of columns and values that we would like to change. We can also optionally set a condition where we're only going to update under these conditions. For example, we can update our users table and set the email equal to John's hypothetical Gmail address where ID is 1, because when we inserted John, he automatically received an ID of 1. If we didn't know that, of course, we would use a select statement to search for John, and then we would find his ID and use that ID to update the data. Or, if we were feeling confident, we could even make the search part of the update statement. We can also delete data from a table using delete from table name and supplying a where condition, as we have many times before. For example, we can delete John by saying we want to delete all of our users that have the ID 1. And of course, since the ID is unique, only John will be deleted. So, that's it for today's lecture. I hope that I wasn't going too fast and that everything was pretty clear. Please don't hesitate to reach out on Slack. Come to office hours with any questions you have. Rahi is going to go a bit more into the technical specifics of how we can work with databases in his demo. I hope you all have a great week and have fun on this week's assignment.